Assalamualaikum, my name is Khairul Anabil Khalid. I am from Group Badang. I am going to present our presentation. So the objective of this project is to design a home which the power is not exceed 5 kilowatt, and the other one is to design a home with a smart control, and also we have a comfort home.
Assalamualaikum, my name is Muhammad Nazrin bin Zaini. So I am in charge for the power scheduling. So basically what we are doing right now is we are still creating the algorithm for the power scheduling on the Simulink MATLAB.
The figure shown is the simulation of photovoltaic array standalone system where we implemented our system integration before into the Simulink software. According to the picture shown, the photovoltaic array receives certain irradiance, which is the unit watt per meter square, and temperature, where we set both value according to the environment in the proposed site. For the power scheduling part, we do load categorization, where we categorize the home appliances into 3 categories, which is category 1, category 2, and category 3. Home appliances are initially classified into these 3 categories. For the category 1, the appliances with the real-time energy consumption mode. For category 2, the appliances with periodic non-real-time energy consumption mode. And category 3 is the appliances with non-periodic. For the first category of appliances, these appliances is directly related to consumer behavior. The energy consumption of this type of appliances cannot be scheduled, and they must run immediately to satisfy the consumer's requirements. For the second category of appliances, the energy consumption is periodical and fluctuant when they are in use, for example, air conditioners and refrigerators. The figure shown is the priority allocation algorithm for the appliances. The appliances commitment can be based upon the necessity of energy consumption by that appliances at any point of time. The need or urgency of an appliance over the others should be considered for an even and efficient scheduling as shown in the figure. This can be ensured by allocating priority to the devices dynamically considering their status. This is applicable only to the second and third category appliances, as the first category cannot be scheduled and must be run immediately.
My name is Kaya Zainwen. Now I will explain about the comfort control. Okay, for the comfort control, we already successful compile the coding for 2 sensors. Okay, for the humidity, we control it by using humidifier and dehumidifier. For humidifier, the coding already successful, but the hardware part is incomplete because we are still waiting for the group water optimization that we bought it online. For the dehumidifier, the coding we use PWM, which is pulse width modulation. This is the technique for control the voltage and power. And for the hardware part, it is still ongoing.
For humidity, we decided to use the closed-loop feedback control system, where the output response depends on the value of humidity that had been set. From this, we can see that the actuator is humidifier and dehumidifier, the process is condensation and evaporating process, and the sensor is humidity sensor. This is schematic diagram for the humidifier that interface with the Arduino. The hardware part for humidifier is still pending because we are still waiting for the group water optimization that we bought it online. This is the coding for humidifier, and we declare the output pin for group water optimization at pin. For the dehumidifier, we will construct the DIY dehumidifier by using peltier that can act as heater or cooler. This device will quickly remove moisture from air by phenomena called condensation, depends on the speed of the DC fan. This is the table for fan speed, PWM values, and duty cycle values. For example, when the humidity value is equal to 50, the duty cycle 20%, and PWM value equal to 51, the dehumidifier will turn on with 20% speed of DC fan. We generated PWM according to the humidity value. This is the flowchart for humidity control. The humidifier will turn on when the humidity reading less than 40%, while the dehumidifier will turn on when the humidity reading greater than 50%.
Okay, Assalamualaikum warahmatullahi wabarakatuh. My name is Naimah Sarah binti Timizi. For the second part of the comfort control, which is the air quality, we have proposed in our previous report, which is to use MQ135 gas sensor and also Arduino and LCD. So as we planned, we managed to get the coding and write the coding. So at the end of this week, we managed to construct and build our DIY devices, which is air purifier, at very low cost. So let's see the demonstration video. So as you can see, all the devices are working. So for the big fan, we are indicate the air purifier, which is the condition will be turned on when the gas sensor is greater than 100. For blue LED, we indicate the dehumidifier that we will using the Peltier. So the condition is greater than 30, it will be turned on. So for the small fan, we indicate dehumidifier which the condition is less than 30 and it is will be using water growth atomization. As we are monitoring and controlling the air quality automatically, we design a closed-loop system. This is because in closed-loop system have feedback mechanism. As long as the desired level of good air and the actual level of good air is not same, the loop will continuously ongoing until the level is same. After the level is exactly same, the loop is stopped. Okay, in this figure, we can see the hardware for MQ135 gases and also the DIY air purifier. In figure 18, it is the flowchart of the gas sensor. So, we define three conditions of the gas sensor. First, when gas sensor greater than 100, the fan will turn on. Second, when the reading of gas sensor is greater than 200, so the fan will rotate spinning at 50% speed. And lastly, when the gas sensor reading greater than 300, the fan will spinning 100% speed, which is the maximum speed. Now we proceed to the current stage of the project. As we are at the end of the week 10, we are able to work on the coding for the algorithm to control the priority of the appliances usage and also the Arduino coding for the EMS. Next, we learn more about GUI, which is graphical user interface by using MATLAB. Third, we are able to work on the schematic diagram and the device to control the control automatically. Fourth, we successfully can compile the programming coding in Arduino, which is using the different sensor. And lastly, we also successfully display the value of humidity and also the level of quality of air on the LCD interface with the Arduino. So next we go to the upgraded work. As you can see in the table, we compared both, which is the preliminary design and also the midterm design. So for the power scheduling, we propose to schedule heavy usage of power consumption. But in this midterm design, we categorize, prioritize, and load priority and also implement the algorithm in the software. So for the power management, in preliminary, we suggest to use EMS, but in the midterm, we propose to use GUI and MATLAB guide, and also backup plan for the Arduino. For the comfort control part, humidifier, dehumidifier, and also air purifier, we upgraded to use PWM technique for the fan speed, and also for humidifier, we still waiting for groove water atomization to complete the device. Thank you.
They encountered issues. We have problem to create an interface and the dashboard from the MATLAB. We need time to complete all the component needed. The electronic component is quite expensive. We cannot display the carbon dioxide contained in the air. Learn the MATLAB usage from all the resources. We built the hardware part where available while waiting the component that we order. Consult with seniors, and instead of displaying the carbon dioxide, we are using indicator.